of a more textured thing where we want to recognize a number between 0 and 199. Again, we won't be concerned with negatives. So we'll assume you don't have to worry about that. So it has to be between 0 and 199 inclusive. So help me unpack this, ladies and gentlemen. How are we going to approach this? Regular expressions are not easy sometimes to unpack, but try to start simple. What things will this definitely include? Okay, we're going to be looking for some sort of thing based on using grep and based on we want to look for things that are words so they're not surrounded by other digits. Okay, so that's good. What other things, what other criteria, what things are we going to try to match? What sort of a unit of matching here? It's, we've got to match, if we're dealing with numbers, we've got to match. Sorry? Okay, digits. I hear the magic word digits, and that's what I'm looking for. Very basic. You've got to match digits, right? Got to be 1, 2, or 3 digits. Now, why is this problem harder than the previous problem? Good. Excellent. Excellent. So, if you have the same difficulty here or none, you can just look for words. How are we going to deal with this? The fact that we only got to 199. Okay. So I'm hearing it. So we somehow have to deal, if we have 3 digits, we've got to deal with the first digit separately to prevent it from going up above 1. Now, you folks will be starting to see here some of the reasons that regular expressions are both very powerful but also very messy sometimes to deal with, to try to impose this sort of limit. But hopefully this will give you some feel for how you can build up regular expressions. Okay, so how about something like this? So could someone here please tell me, please interpret this regular expression for me.
There may or may not be 0 or 1 preceding what we had last.
Okay. Preceding 1 or 2 digits in the range 0 to 9. And how about these outer sort of delimiters, the backslash, less than, backslash greater? What are those? What's the meaning of those? Yeah, it has to be surrounded by things that are not alphanumeric characters. It could be, again, it could be surrounded, it could be at the beginning of the line or at the end of the line, or surrounded by things that are spaces or stars or whatever, but it can't be surrounded by things that are alphanumeric. Okay.
It's just another way to say what we did with that W.
That's with the, that's right. You would have seen a W case, in fact, we'll be returning to that. It's another way of comparison. You could approach it using the backslash W character, backslash capital W as well. Okay, so this is worth a shot. So suppose we would give this 0. Would this work? Here? We give it 0, is it going to work? Okay, what is it matching? How is it going to match it? Where does the 0 get matched? Is it matching this thing? Is it matching this thing? Or something in here? Which one is it matching? The middle one. It's seeing this as a single instance of this 0 to 9. That's what matches the 0. This one is just, it says it's not there, so it's going to match it here. And that's all there is. There's not 2 of these, and so that's all it's going to match. Okay, so how about this 99? Which one of these components of it is it matching here? So this 99, tell me which ones these match. Which part is it actually exercising? Which part is actually matching successfully? It says first component matching? No. It's matching this, and it's allowed to repeat 2 times, so it's taking advantage of that and allowing it to match twice. Okay, so that's great. How about 199? Now what's matching? Is the first one? Yeah, now that is, then this is again, and this again twice, right? Okay, so that's good. So how if we had 19? Which would that match? Instead of 199, how if it was 19? Which parts of this would be matched? How many people say the middle part twice? How many people say the first part of the middle part once? Yeah, that's what it is. It's greedy. This guy's trying to say, hey, can I match a 0 or a 1? Yeah, you can, and still match this later. If it did a 0 or 1, for like, suppose it were just 1, could it say, can I match that? Yes, but then this wouldn't work, so I can't in fact match that. Here, with 19, it can match this, and this matches. The 9 matches this with just 1 repeat, and so it's happy. Okay, so you can kind of think it as trying to match that first piece, and if it's consistent with the constraints on later pieces, then it does match. Otherwise, it backs up to, okay, I can't match this first one. We have to do it for the second too. So for example, 99 obviously doesn't match this 199. Yeah, it does match this, and then the second 9, the 9 can be matched by the 0 to 9 twice. 19, it will match this first one, and it can match the second one just fine. But if you had just 1, it would think it might be able to match here, but then it can't match this whole later one, so it's not going to match here instead. It's going to match. Gotta kind of learn to think about this. It's trying to match with this question mark case, but if it has to sacrifice that first one with the question mark to be able to match the later one, it's willing to do so. Does that make sense to people? Yes.
With the 19, or if you suppose the 0, 1 was on the other side, which is the right, would it 0, 1 match both of them, or would it?
So say this question mark were over here instead, you're saying?
Say the whole 0, 1 question mark was on the right, and then it had to match 91.
It had to match 91, yeah. Yeah.
Would it match the 0, 9 twice, or would it match 0, 9, then do 0, 1?
It's a good, it would match the 0 to 9 twice. It's greedy. It tries to match it. As long as the later constraints can be satisfied down the road, it'll try to match as much as it can there. So if this, to answer this question, maybe make it less abstract to people. Let's strip this out here, and let's sort of, if we had something like this, and we were to put this over here and make it 91, would this match? The answer is yes. How would it match it? So this first one would match, the 9 would match here. Now, the 1 could be matched also, and it would be fine with this later constraint. So it'll match just fine. But if we had instead, so this would match to 91. If we had instead this sort of situation, where this was something like that, tell me what would happen then. How would this, which would match, first of all, would 91 be matched by this? Yes. Which one would be matched by this first expression sort of here? The 9. You would think it could be repeated and match the 1, but why doesn't it do that? Because this guy still needs to be satisfied. And you can't match both the 9 and the 1 with this and still leave this guy okay. And so it needs to leave that 1 to be interpreted by this to match the full expression. So it's going to match as much as it can and still leave the later things satisfied. That's what I mean by greedy. But it's not going to, it won't match, as much as it can if it means making the later ones not work. Does that make sense? Yeah. Okay.
So really, they're not especially greedy because they'll still share, even though they want as much as they can, as long as they still.
They want as much as they can, as long as they can share such that it all works out perfectly. Yeah. So you're right. They're not. Maybe they're avaricious but not greedy. I don't know the right term for that. They're as long as they can make everyone work, they'll take as much as they can. Right? Okay. So you can think of that as kind of recursive way. You can think of it as kind of backtracking. Okay, we'll try matching, as much as possible here and going forward. But if it's not going to work later, we'll come back and try another option that will work, etc. But this is one of the things that makes reading these regular expressions a little bit tricky, that, it might be able to be parsed, it might be able to work out in several different ways, and you got to kind of get into this mode of thinking, okay, match as much as possible, but still let the later things work, okay? Okay, so here we are, we're matching this 0 to 1, which may occur, and then 2 subsequent digits, which could be anywhere from 0 to 9. This initial one won't be present if you just have something like 99, but it will be present if you have 199, and it can only match 0 and 1 here. Okay, so you'll notice that this does match, for example, 0, 0, 0, 1. Okay. So how if we want to write a regular expression to identify a 1 or 2-digit number in the range 0 to 55? What will we do? Again, we're trying to get digits here.
0 to 5 says 0 to 9.
Okay. Why won't that? So it's a fine idea. So I like to encourage people to come forward with an idea. Will that work? Instead of 0 to 9, we get 0 to 5. What would that work for? 49. It's in the range 0 to 55, but it wouldn't be matched with something that's just from 0 to 5 as a digit. So that won't work. So how are we going to crack this nut? How many people think this could be done? It can be done. How are we going to do it? Well, it turns out we need greater flexibility. So here's the answer. Someone help me understand this answer. It looks ugly as sin. I mean, it's not pretty to look at, but there's a logic. There's a method behind its madness. So first of all, let's start from the pieces and work out. Okay, so what's the innermost sort of operator here? I could diagram this out as an expression, but saying, okay, what we have is a bar expression. What does that bar expression mean? It means or. You match something on one side of it or another. So we have a sort of, this is not good. I'll put a hole in the middle of the bar so you can distinguish it. This is sort of a line here. And this is the bar operator. This is an operator at the top level. And on the left, I have this sort of concatenation of two things. I have 0 through 4, and then a question mark operator, and then a 0 through 9. Yeah. And on the right, I have a 5, and then it's something at range 0 to 5. Okay, so help me understand what's going on here, folks. So what is the job of this thing on the left here? Good. And to do that, it needs to match things that are either one digit or two digits, right? So there might be something like 6 or 9 by itself. It needs to be able to match that. If I just gave it, suppose I gave it 6 or 9 or 0, what is that going to match? Which part of this expression will match it? So the 0 to 9 component right there. This 30, this is a case where my, I wish we were Yao Ming or something. Okay, so, you folks are probably more entertaining lectures if I were Yao Ming too. I don't know, people talk about breath anyway. So this 0, what is it matching here? I could also use the mouse. Okay, so this 0, what is it matching here? It's matching this guy. This guy would love to match it, but he can't match it and have this, either this thing succeed or that thing succeed. So he can't match it, so it's got to be matched by this here. So 45, what would that be matched by? 4 and then a 5, right? How about 56? Won't be matched at all. How about 55? Okay, it will be matched here. So if we had 9, where would that be matched? There. If we had 19, where would that be matched? Okay, so it would be matched here and then there, right? So this is basically handling the case where we have a 2-digit number and we have something of the first digits between 0 and 4. We can handle just a single-digit number, but if we have a 2-digit number, it can't go above 50. To 50 case will be handled over here. So here we handle all things between the first digit is 0 to 4, and then we have a subsequent digit 0 to 9, or we have things in the range 5 and then 0 to 5. Okay, so this does in fact work. This works to match that. Okay, I think I'm going to leave this in the slides. How would you approach this if you had to approach this problem without going into it in great detail, because I want to get on to some other types of examples? How would you approach this? Yeah.
Tack it onto the previous one.
Okay, a very similar idea here, but would it be more complicated? Turns out, yeah, it's actually a little bit more complex. I mean, after all, we have to be able to handle this 0, 1, 2 here, and it could go up to 249 here, but otherwise it can go 250 up through 255. Okay, so we kind of break it into these cases where here we're matching things that are single digits. We're matching things that are double digits. For example, if we have 99, excuse me. So actually, this is not going to work. We want to match double digits, but it's not going to work because we have 99. Will 99 match this? Okay. So this is actually an expression which will work. So suppose I want to match 9 by itself. What would that match? Okay, 0 to 9 a single time. How if I want to match 99? 0 to 9 twice. How if I want to match 199? 1 and these things. If I want to match 240, where would that match? This guy here and then the second one. How about 253? Then you have to have this other one here. So you'll notice this is handling sort of 3 special cases. One is the general case up to 199, and then it has to handle the 200 case up to 250. Why does it have to handle that? Especially. Why does it have to handle the case up to up to but not including 250, from 200 up to 249 separately? Yeah, because the second digit can't be, above 4, and so it has to be able to handle that. And then it has to handle the case of 250 specially, because the last digit. Yeah. So here, it's handling the 250 case because the last digit is constrained. Here, it's handling the case 200 to 249 because the second digit is constrained. The full, it can't be more than 4. And then it's handling sort of all cases less than 200. So, is this ugly? Yes. Yes. Yeah.
Could you take what you had before, which is 55, put brackets around it, and put one, two, square brackets, question mark around it?
That's a good question. So, I think the question here is for this guy, could you put around this second one right here? 55. Put a plus around it or something?
One doesn't work. Why don't they handle 0 to 55, and then 1 to 55?
Yeah, that's unfortunately not going to work. You do need these 3 special cases. And I mean, this is horrible. This is getting like to the limits of regular expressions, but it does teach you how to start to think about them and some of the logic behind composing them. But fundamentally, you're dealing here with the fact we're treating them as characters and we're not as numbers. In fact, in a lot of cases, you'd be better off converting it to a number and then just comparing it, in a program you write. Okay, but let's look at something that is more textual based, somewhat more textual based at least. So here we have a set of hexadecimal numbers separated by colons. So 6 hexadecimal numbers. These are 2-digit hexadecimal numbers. So it can be, what's a hexadecimal digit like? Yeah. And probably either upper or lowercase a. And they're separated by colons. So someone suggests this. This is less horrible. Could someone suggest this? It's actually more straightforward, quite a lot, so.
Well, you just have the sort of 0 to 9 and then 8 to half.
Yeah.
And then you have 2 of those.
Okay.
And then a colon times 6.
Okay. So, yeah, we'll start with the expression which you mentioned for a 2-digit hexadecimal number. We'll work up from there. So this is the sort of thing you suggested. 2 of these guys, that will match that sort of basic unit, and you can test that out, and this is a good thing to do. Give it a test by itself first, and then we want to string them together. Now we could just do this, followed by colon, followed by this again, followed by colon, followed by this again, followed by colon, followed by this again, etc. That would be the brute force way to do it. Another way is you do it this. So help me understand what this is saying, folks. So it's overwhelming to look at it first, but let's break it into pieces. So what is this last piece doing?
Back to the end, but there's no colon after the next.
Okay, it's dealing with this case at the end. There's no colon after it. So the last case. What is this preceding expression? Okay, so matching 5 of these whole things, each of which consists of 2 of these hexadecimal digits followed by a colon. So we have 2 hexadecimal digits and colon, and that's repeated how many times? 5 times in a row. And then we follow it by 2 hexadecimal So we could give this sort of thing, and we'll print it out, and we could give it something that's ill-formed, for example, it's missing the final one, and it won't print it out. Why doesn't, ladies and gentlemen, why doesn't this one work? This one, I'll just tell you, it's missing the final little, like there is a code of the two hexadecimal numbers in the colon. Why isn't this matching? What?
Exactly 5 plus 1.
Yeah, so does it match this part of it?
No. It matches the
Good. It actually matches it 4 times, and it can't match this final colon. So this actually fails. If we had a colon there, it would match this one, but it wouldn't be able to match that one. Does that make sense? Okay. So this is a simple case. Okay. Yeah. Does this match? Suppose we had foo before it and foo and bar after it. Would it still match? Yeah. It doesn't care anything about its context. It's just saying look for this anywhere in the line. Just match it. It doesn't say what has to be before it or after it. So if we want to have it surrounded by things that are not only by things that are not words, you can't have foo bar before it or other digits before it. You could do something like this. Okay. Okay, I think I'm gonna skip this one, IPv4 addresses. It's kind of a similar idea. Okay, so here's another example. Let me sort of carve this off.